Okay, my name is Raz Dechantal, and this is for the task 3B, OBF 3B. And the task is basically to combine a RAM and ROM component and to show that in the RAM component, once we enable the write operation, then we can change the value in the address data, and in the ROM we basically don't have the write operation, we only have the read operation. So here, as you see, that I have combined RAM and ROM both in the one code and in the one component, in one port that we have address RAM, data RAM, and this is for read write operation that we enable it or disable it. And then we have another output variable which reads basically from the data RAM. So and for the ROM we have this address ROM, and then we have Q ROM, which basically a reflection of the address ROM here. So here we have the architecture, which we have this variable which is an array called ROM type, and that way this is a fixed length array that it has 4 values: 1, 2, 3, and 0. How it works, we have three different processes. The clock process, which with the rising edge of the clock, we set up this RAM operation, we enable it, and then we can read from the data RAM into that. And then we also check that these values from the address RAM comes to the Q RAM, and we basically assign that value to the Q RAM here. And then in the ROM process, in the rising edge of the clock, we basically read from the ROM, and that's it. And there is no write operation in here. For that, we have a test case here, this test bench in here, that we have some signals like add RAM, add ROM, have clock, data RAM, QRAM, and VRAM for the enabling write operation in here. As you see that we have 3 processes in here. One that is activating the clock, setting the clock 0 and 1 in every 10 milliseconds. We have a constant here which is 20 nanoseconds, and here every 10 milliseconds we have 0 and 1 that simulates our clock. And for the ROM process, as you see here, we have a fixed length array, which again we have set some fixed values in here, 1, 2, 3, and 0. And we have a loop that which corresponds to the number of the slots in our array, and we go from 0 to 3, and we check that we read the add ROM from our address ROM, and then we give that to our Q ROM, which is the code in here inside the design code, which takes the value from the address ROM. To make sure that this code is working, we use this assert to see that if QROM values is what we have in the expected values in here, which is basically a fixed size array for example, when we are in the first round of the loop, with index 0, it reads the index 0 from this expected values, which has to be 0, 1, and then 1, and then it has to be 2 and 3 and 0, and so on. So that is how it's validated with this assert statement here, and if it's not doesn't hold, then we in the simulator we get this error message. And for the ROM, we have some initializations. For the RAM, we have some initializations. That the first set that the VRAM to the 0, address RAM to the 0, and data RAM to the 0. And then again, we have a loop, 4 runs loop from 0 to 3, that we basically enable reading, and then we give this address RAM and then data RAMs from the expected values. So for the first one, we set the address using the loop index, and for the data RAM, we set the data according to the expected values, as you have. Then we wait for 2 cycles, constant that we have here, which is 20 nanoseconds. And then we give enough time that all these values are set, and then wait for 2 cycles, and then we set again to the 0. And then we wait for 1 cycle, because we don't change much here, and that should be enough. Then we check that the QRAM is equal to data RAM. If not, then we throw a message in here. And now I want to show you how it works in our simulator, which is in here. And as you see, for the ROM test, we have let's say that we have these signals that we can see in here. For the ROM, that we can see that for every clock cycle we have different values: 0, 1, 1, 0, 1, 2, and 3 in here. So that's for the ROM. For the RAM, however, we have a little bit is a little bit different, and you see that there is also a little bit shift when you're talking about the ROM operation, the ROM process. If I just put it in here, that would be a little bit. So we have a little bit shift in time because of that 1 cycles that we're waiting for the I'm sorry, we are here. So we, for the ROM operations, we have a little bit time it takes that the value from the address ROM is read from to the Q ROM. So then that would be about about 10 nanoseconds and half a clock cycle. So when we have 0, 1, 2, and 3 here, then we have 0, 1, 3, and here again we have 0 here, because we first initialized it to 0 in this one. But for the RAM operation, as you see here, that we have zeros in VRAM, though we cannot write anything. Then once we have here 1, then we can say that our QRAM and our address RAM, our data RAM and the QRAM here is starting from here. Data RAM and QRAM are the same. It takes a little bit time at the beginning, and then we set again the VRAM to 0. Then again, after only 1 clock cycle, we set it to 1. Once we set it to 1, that you see that QRAM and data RAM, it takes a little bit time in here. Then they are both the same, because we wait about 3 clock cycles for changing that. Again, we have here to disable the write operation, but here we enable, and then first we see that our data RAM is changed, but it takes another clock cycle that, okay, they synchronize together. See here 1 0 1 0. The same goes to the end here. Then we have again 1 1 1 0 because we need to wait 3 clock cycles, and then we read the QRAM and we test it if it is the same, and it's okay. So it all holds with our design, our test bench code, yeah, that's it. And we have no error messages in here, so everything is working. So thank you, and that is the end of this video.